Now see in this question, this question is actually based on the elastic potential energy stored in a stretched wire. A steel wire of 6 meter length is stretched through 3 millimeter. It means you are given L is equal to 6 meter and this delta L is equal to 3 millimeter, that is 3 into 10 raised to power minus 3 meter. Area of cross section is given to you, this 2 millimeter square is equal to 2 into 10 raised to power minus 6 meter square. Now, Ys, that is Young's modulus of steel, is given to you. You have to find elastic potential energy density. So, already we have derived the formula, energy density is equal to half into stress into strain. But see here, stress is not given. We have not given also force. So, we can go for the another option, that is a stress we can change. We can write half into, in place of stress we can write Young's modulus into strain, and already strain is here. So, that will be here strain square. So, in place of stress I have written Young's modulus into strain. So, now we are given 2 into 10 raised to power 11 and strain already is given to us, that is here this delta L and this L. So, we have got 3 into 10 raised to power minus 3 upon 6 square. So, that will be here joule per meter cube. So, when you solve it, this and this will get cancelled, and here this is 2 is here. So, we will be getting here 1 upon 4 into 10 raised to power 5 joule per meter cube, and that you will be getting 0.25 into 10 raised to power 5 joule per meter cube, and this will be the energy density. That can be also written here 2.5 into 10 raised to power 4 joule per meter cube. So, now we have calculated energy density, that was I think that is 2.5 into 10 raised to power 4 joule per meter cube. Now, we have to calculate elastic potential energy stored. So, that this is the energy per unit volume. So, the total energy, that is U, is equal to, we can write here 2.5 into 10 raised to power 4 multiplied by volume of the wire, that is A into L. So, see here 2.5 into 10 raised to power 4 into A is given to you 2 into 10 raised to power minus 6 into, this is 6, that is joule here, and it will be coming here 0.3 joule.